Welcome to G Fun Facts Online, where we dive into the universe's biggest mysteries. We often picture planet formation as a calm, orderly process, a gentle gathering of dust in the quiet suburbs of a galaxy. But what if I told you that some of the most dramatic, violent, and downright hostile places in the cosmos are also planetary nurseries? From the gravitational chaos of two suns locked in a cosmic dance, to the searing radiation baths near giant stars, and even the mind-bending abyss around a supermassive black hole. Today, we're exploring the story of cosmic resilience, how planets are forged in fire, and how these extreme worlds might be the perfect homes for the toughest life forms imaginable. Let's start with a cosmic tango. For a long time, scientists thought that binary star systems, where two stars orbit each other, were terrible places to build planets. The constant gravitational tugging from the second star was thought to act like a giant egg beater, stirring up the disk of gas and dust so violently that any small particles would just smash into each other and break apart, instead of clumping together to form planets. But it turns out, nature is more clever than that. Recent research has found a few key ingredients for success. First, if the building blocks of planets, the planetesimals, can grow to about 10 kilometers in diameter, they become gravitationally strong enough to survive these high-speed collisions. Second, the shape of the dusty disk matters. A nice, circular disk helps to soften the disruptive pulls from the companion star. And finally, the gas within the disk itself helps create quiet zones, where planet construction can proceed peacefully. Observatories like ALMA and the Keck-2 telescope have given us a front-row seat to this process. In the binary system SVS13, for instance, astronomers see a disk around each star and a larger shared disk that's feeding them both. It's like a stellar buffet line for planet formation, suggesting that the process is far more robust than we ever imagined. Now let's turn up the heat. Many stars are born in crowded clusters, shoulder to shoulder with massive, brilliant stars that blast their surroundings with intense ultraviolet radiation. This UV bath was considered a death sentence for budding planets, a process called photoevaporation that would literally blow away the gas and dust from a protoplanetary disk before it had a chance to form anything. But once again, the universe has surprised us. New observations from the James Webb Space Telescope and ALMA are telling a different story. In the Lobster Nebula, a young sun-like star called XUE-1 is being blasted by its massive neighbors. While the radiation has eroded the outer edges of its disk, the inner part is holding strong, containing enough material for multiple planets and even key molecules like water vapor and carbon dioxide. Similarly, in the Sigma Orionis cluster, we see telltale rings and gaps in the disks, the clear footprints of newly forming giant planets. So how do they survive? The secret seems to be speed. In these high radiation zones, planets have to form fast before their cradle of gas and dust is blown away. And the key to forming fast is a higher concentration of heavy elements, or what astronomers call metals. These elements allow dust grains to stick together more quickly, giving planets a crucial head start in the race against destruction. But what about the most extreme environment of all? What about the shadow of a black hole? It sounds like science fiction, but Japanese theorists have proposed that planets can form around the supermassive black holes that sit at the center of most galaxies. These black holes are surrounded by enormous, donut-shaped clouds of dust and gas called tori. These tori can contain 1 billion times more dust than a typical planet-forming disk. Inside these dense clouds, the intense radiation from the black hole is blocked, creating cool, calm regions where icy dust particles can stick together and grow. The calculations are stunning. They suggest that tens of thousands of planets, each perhaps 10 times the mass of Earth, could be forming in a region just 10 light-years from a black hole. These so-called planets would live in a truly bizarre setting. They wouldn't have a star to orbit, but the glowing hot accretion disk of the black hole itself could provide light and heat. perhaps even enough to create conditions suitable for life. The discovery that planets can form in these hellish environments begs an incredible question. Could life exist there too? If it does, it would likely be in the form of extremophiles, organisms that thrive in conditions that would kill most life on Earth. Here on our own planet, we find them everywhere, in the boiling water of deep-sea vents, under the crushing pressure of the ocean floor, and even bacteria like Deinococcus radiodurans, which can survive massive doses of radiation and the vacuum of space. These tenacious organisms expand our definition of what's possible for life. They allow us to imagine how life might adapt on a world with two suns, or a planet constantly bathed in UV light. An organism there might have super-efficient DNA repair, just like our radiation-proof bacteria. Life on a planet might evolve to harness the strange light and energy from its black hole's accretion disk. The universe, it seems, is far more creative than we give it credit for. The fact that planets can be born in these chaotic crucibles is a testament to the sheer resilience of the cosmos. And as we find more of these extreme worlds, the possibility of finding life in its most unexpected and tenacious forms becomes more and more real. Our search for life beyond Earth might just be a search for the ultimate extremophiles of the cosmos. Thanks for joining us on Fun Facts Online.